Hey everyone, so we're going to be working again on rigid transformations. And again, just to kind of recap, rigid transformations, we talked about shifts, which is when we're sliding left, right, up or down. We talked about our flips, or we called them reflections, right? Flipping, we talked about flipping our hand. So see how our thumb moves from one side to the other when we flip our hand. We talked about that a little bit. Or another word for that is a mirror. And then we also talked about our last one, which was a turn or a rotation. So we want to make sure that we're trying to use those technical terms. So again, a shift is a translation. A flip is a reflection. And a turn is a rotation. So we want to make sure we're using those fancier terms, those mathematical terms, when we're talking about our transformations. So today we're going to describe a little bit how shapes are getting from one place to the other. So let's go to this right here, to our warm-up. For our warm-up says that Andre is performing a 90-degree counterclockwise rotation of a polygon P. So, okay, counterclockwise, the opposite way of the clock. So, if you think about a clock, we have a clock here. It normally goes this way. But since we're doing counterclockwise, we have to go the opposite way of a clock, which is this way. So that's the way we're going to be turning. So we're going to be taking this guy P right here. See how it's labeled there? And we have to turn him this way to get him to be at P prime. So say Peter, maybe this is, P stands for Peter here, this is his shape. He wants to change a little bit. He wants to have a new change in his life. He's going to go to Peter prime. So he's just going to mix it up just a little bit. Now we need to find out how Peter or triangle, not triangle, shape P, polygon P is getting from P to P prime. How is he changing? So let's take a look. If we're looking here, we want to find where, whenever we rotate, that point would match up. If we move this guy, this little point right here, it would have to match up with this point right here. Is there a way that we could rotate that 90 degrees? Again, remember that 90 degrees, we have to create that right angle. Well, let's see. This guy is 2 away that way. And this one is 1, 2, 3, 4, 5, 6 away. So they're not the same distance away if we rotated around this point right here. They'd be different distances away, and they wouldn't line up. We have to make sure that they're the same distance away. So since that doesn't work, let's try another point. We also see that this point down here and this point right here match up. Again, in order to rotate that and make that 90-degree angle, they have to be the same distance away from the point of rotation. So the point that you're rotating from. And how I like to find the point of rotation is I like to just draw a line like across here and then a line across here. See how it makes that 90 degrees? And I like to make sure they're the same distance away. So this one, our point would be where they intersect right here. That's our point of rotation. So I see 1, 2 units here, 1, 2, and then up and down for this triangle, I see 1, 2. So they are the same distance away, which means they would be able to create that 90-degree rotation if we used this wonderful point that we found right here. So that right there would actually be our point of rotation. And you can double check on the other points right here that they line up with and see if they work. But you want to make sure, again, they're the same distance away from your point of rotation when you are rotating from P to P prime with 90 degrees.